So let's see, for any regular language L, what the size of NFA and DFA? This NFA, where you have number of states is equal to n, and if you apply this algorithm, this subset construction algorithm you apply, you will get equivalent DFA. Okay, if you apply this algorithm, then you will get equivalent DFA, remember. Okay, you will get equivalent DFA. We have already seen that this DFA will have maximum 2 power n states using this algo. Okay, yes or no? Using this algo, maximum 2 power n states you will get in the equivalent DFA. So tell me, the minimal DFA will have how many states? This DFA already has less than equal to 2 power n states. Remember, this DFA may or may not be minimal. Yes or no? This DFA that you are getting, this may or may not be minimal. This may or may not be minimal. Agree? This DFA may or may not be minimal. So this DFA that you are getting, this has 2 power n states. This DFA D, this D has at most 2 power n states. Okay, so tell me what the minimal DFA. If you minimize it, then number of states will reduce or not? The number of states will reduce or increase? Tell me about the minimal DFA, because minimal DFA is unique. Tell me about the minimal DFA. Minimal DFA will have less than equal to 2 power n states. Yes or no? So finally, I can say that minimal DFA has less than equal to 2 power n states. Okay, is this point clear? Please tell me. Very simple. This NFA, if you convert to equivalent DFA using subset construction algorithm, then maximum you will get 2 power n states. This is the maximum you will get. But remember, this DFA that you will get, it may or may not be minimal. Either it may be minimal or it may not be minimal. So if this DFA you minimize, then number of states may reduce. Yes or no? Number of states can reduce. Okay, so that is the reason I can say that minimal DFA has at most 2 power n states. Minimal DFA will have less than equal to 2 power n states. This is the final conclusion, that for every NFA of n states, the equivalent minimal DFA will have maximum 2 power n states. This is very important point, that for any NFA, remember, for any NFA of n states, for any NFA of n states, equivalent minimal DFA will have maximum how many states? Equivalent minimal DFA will have how many states? Equivalent minimal DFA will have at most maximum 2 power n states. Okay, is this clear? And remember, this minimal DFA, this is actually unique. You already know that this is actually unique. Okay, so this is what I'm saying, that if you take any NFA of n states, then equivalent minimal DFA that will have maximum 2 power n states, less than equal to 2 power n states. Tell me the answer for this question. Can you give me a language where NFA has n states, but the minimal DFA has almost 2 power n states? Yes, very easily you can give a language. What that? For example, if your sigma is a comma b, if your alphabet is a comma b, then consider this language where kth symbol from right is a. Kth symbol from right is a. Okay, we have already seen this. For this language, minimal NFA have how many states? In the previous lecture, we have seen this. Minimal NFA, how many states will be there? Kth symbol from right is a. Minimal NFA will have how many states? That will be k plus 1 states. Yes or no? But minimal DFA, how many states? But minimal DFA, how many states? That is 2 power k states. Okay, so can you notice that NFA has almost k states and minimal DFA has almost 2 power k states? For example, okay, if you have, let's assume in the same question, let's assume that you have a 10th symbol. Okay, let's assume you have a 10th symbol. Then minimal NFA will have how many states? There will be total. Tell me, how many states in the minimal NFA? There will be 11 states in the NFA, and there will be 1024 states in the minimal DFA. Okay, so you can see the question is asking that give a language for which NFA has n states and the minimal DFA has almost 2 power n states. So you can see this type of language is this. Kth symbol from right is a. Here you can see minimal NFA has k plus 1 states, and minimal DFA, it will have 2 power k states. This we have already seen in the previous lectures. Let's solve this GATE 2018 question. Let n be a NFA with n states. Let k be the number of states in the minimal DFA which is equivalent to n. Which of the following is necessarily true? Here remember, this NFA is given to you which has total n states, and the question is asking that number of states in the minimal DFA. In the minimal DFA which is equivalent to n, then number of states in this minimal DFA, what that will be? We have already seen that for every NFA, the equivalent minimal DFA will have at most 2 power n states. Yes or no? If you have an NFA with n states, then equivalent minimal DFA will have maximum 2 power n states. So for this question, the answer will be that k is the number of states in the minimal DFA which is equivalent to n. So this k, this will be definitely less than equal to 2 power n. Okay, n is the number of states in the NFA. So for this question, answer will be option D. Very simple. Now tell me the answer for this question. This is GATE 2008 question. N is NFA with n states, and M is minimized DFA. M is minimized DFA, minimal DFA. So you can see this is a minimized DFA with M states recognizing the same language. Means they are equivalent. This NFA and this DFA, they are equivalent. They recognize the same language. Which of the following is necessarily true? So tell me, you can see this NFA has n states. Then I told you that if you have NFA with n states, then equivalent minimal DFA will have at most 2 power n states. Yes or no? And you can see here the question is talking about minimal DFA. So this minimal DFA which has m states, this m will be less than equal to 2 power n. Okay, so very simple. The answer for this question will be option A. This is GATE 2001 question. Given an arbitrary NFA with n states, the maximum number of states in the equivalent minimal DFA, how much will be that? Tell me, maximum. The question is asking maximum how many states can be there in the minimal DFA, in the equivalent minimal DFA. Let me know. So you have NFA with n states. I'm asking in the equivalent minimal DFA, in the equivalent minimal DFA, maximum how many states can be there? Maximum 2 power n states can be there. Yes or no? Maximum 2 power n states can be there, remember, because you already know that in the equivalent minimal DFA, the number of states will be actually less than equal to 2 power n. So this is the maximum value possible. So this is the maximum possible. Okay, the question is asking about maximum. So here the answer will be option B. Okay, let's move on. Tell me the answer for this question. This is 1987 question. State whether the following statement are true or false. A minimal DFA that is equivalent to NFA with n states has always 2 power n states. Is this statement true or false? A minimal DFA that is equivalent to NFA with n nodes has always 2 power n states. This statement is actually false. Why this statement is false? See, this statement is saying that we always have 2 power n states. The minimal DFA will always have 2 power n states. But this statement is false. Why? Because actually this minimal DFA will have less than equal to 2 power n states. Yes or no? We cannot say that it will always have 2 power n states. We can say that it will have less than equal to 2 power n states. Yes or no? So this is saying it will always have 2 power n states. This statement is false. But in the same question, if I say that has at most 2 power n states, now what? In the same question, if I say that it has at most 2 power n states, now this statement will become true. Now this statement will become true. Now we will solve this question. This is a nice question, but there is a mistake in this question. So we will solve this question, but before that, let me ask you some questions. Read this question and tell me, is this true or false? For NFA with 3 states, you have NFA with 3 states, there exists equivalent DFA with 20 states. Is this statement true or false? For NFA with 3 states, there exists equivalent DFA with 20 states. This statement is true. Why this statement is true? Am I talking about the minimal DFA here? Am I talking about the minimal DFA here? No, I am not talking about the minimal DFA here. See, I am talking about DFA. You can have DFA with 20 states, right? Notice one thing. See, very simple point. You have NFA with 3 states. Okay, there is NFA with 3 states. Now tell me, if you convert this NFA using the subset construction algorithm, then the DFA you will get, yes or no? You will get equivalent DFA. See, you will get equivalent DFA. With how many states? With the maximum how many states? With less than equal to 2 power 3 states. Do you agree? If you use this algorithm, remember, if you use subset construction algorithm, the subset construction algorithm, if you use, then this NFA, if you convert to equivalent DFA using subset construction algorithm, then this equivalent DFA you will get with at most 8 states. Yes or no? Okay. But notice one thing. Here, please notice one thing that so you already have a DFA, you already have a DFA with at most 8 states. So can I add some unreachable states and can I make it 20 states? Let me know. You have a DFA, remember, with at most 8 states. Now what I can do, notice, for the same language, can I add unreachable states? Add some unreachable states. What I can do, I can add some unreachable states and make DFA of 20 states. Can I do this? And make DFA of 20 states. If I do this, will the language change? I'm adding unreachable states and I'm making a DFA of 20 states. Will the language change? The language will not change. Yes or no? So can I say that for this NFA, you are getting an equivalent DFA? Yes or no? You are getting an equivalent DFA because they have the same language. This NFA and this DFA, they have the same language. And you can see that this DFA has 20 states. Is this point clear? Please tell me. So remember, this is not minimal DFA. Not talking about minimal DFA. I am not talking about minimal DFA. Remember, minimal DFA is unique, but DFA is not unique. Okay, yes or no? Please understand that minimal DFA is unique. DFA is not unique. Understand this point very carefully. That minimal DFA is unique. This is unique. Okay, but DFA is not unique for any language. Agree? So this is the point that for any regular language, remember, minimal DFA is unique, but DFA is not unique. For example, let me explain. Like, let's assume that you have this language that is sigma star. You have this language that is sigma star, means A or B whole star. This is the language you have. I can create DFA. I can create DFA with one state. So here, what I can do, I can create DFA with one state. For example, this DFA I can create. This DFA has one state, but I can create some other DFA also. Okay, what I can do, I can add unreachable state and I can create another DFA also. For example, what I can do, I can create another DFA also. Let me put like this. This is the state Q0, this is the state Q1. Okay, so I can do like this. Now this is your DFA with the two states. The same language, yes or no? The same language. The language is not changing. The same language, but this is the DFA with two states. I can create another DFA. I can create, for example, DFA with 5 states. What I can do? Notice, for the same language, I'm not changing the language. For the same language, I can create DFA with 5 states. I can just keep adding unreachable states. Yes or no? Do you agree that I can keep adding unreachable states? Now I got DFA with 5 states. Okay, yes or no? For the same language, I got DFA with 5 states. There are total 5 states here for the same language. So this is what I'm saying. Minimal DFA is unique. DFA is not unique. Okay, so now you tell me the answer for this question. For NFA with 3 states, there exists equivalent DFA with 20 states. There exists equivalent DFA with 20 states. This statement is true, right? Because what you can do, notice, this NFA you can convert into minimal DFA. In that minimal DFA, you can add unreachable states. Yes or no? This NFA you can convert into minimal DFA. Minimal DFA will have at most 8 states. in that minimal DFA, you can add unreachable states, keep adding unreachable states. Then you will get a DFA with 20 states. So this statement is true. Do you agree? Please tell me. Let me ask you the next question. Tell me the answer for this question. You have NFA with 3 states. There exists equivalent minimal DFA with 20 states. There exists equivalent minimal DFA with 20 states. This statement is false. Yes or no? Because remember, equivalent minimal DFA will have less than equal to, it will have less than equal to 2 power 3 states. Okay, let me know. Tell me the answer for these two questions. See, understand the difference between these two questions. This statement S1, statement S1 is saying that for NFA of 3 states, there exists a equivalent DFA, equivalent minimal DFA. Here, equivalent minimal DFA with 20 states, this statement is actually false. Yes or no? This statement is actually false. But remember here, in the S2, there exists a equivalent DFA. So this statement is true. Because DFA is not unique. Yes or no? This DFA, this is not unique. Okay, but remember, minimal DFA is unique. So did you understand the difference between these two statements? Let me know. Now let's see this question. Tell me the answer for this one. For NFA of n states, you have NFA of n states, there exists equivalent DFA with more than 2 power n states. Is this statement true or false? Let me know. See, a student is saying that, okay, let me take this doubt. A student is saying that, sir, using subset construction algorithm, the DFA that we will get, that will have maximum 2 power n states. I agree with you. Okay, if you apply this algorithm, if you apply this subset construction algorithm, then you will get DFA, which will have maximum 2 power n states. But who told you to apply this algorithm? Are you getting my point? To do anything, is there only one algorithm? Who told you to apply this algorithm? In this question, am I telling you to apply this algorithm? Read this question. In this question, am I telling you to apply this algorithm? See, this subset construction algorithm, this is just one algorithm. Okay, if you have some NFA, you apply the subset construction algorithm, then you will get a DFA with maximum 2 power n states. Now, this DFA that you will get, which has maximum 2 power n states, I can add unreachable states. Okay, see what I'm doing. You will apply the subset construction algorithm. You will get DFA with maximum 2 power n states. Now, what I will do, in this DFA, I will add unreachable states and I will increase the number of states. Can I do that? Without changing the language, can I add unreachable states and can I increase the number of states? Yes, I can increase the number of states without changing the language. Yes or no? This is what I'm saying. That DFA is not unique. You can create DFA of 1,000 states, 2,000 states, 10,000 states. Who is stopping you? Are you getting my point? See, if you take any language, for example, consider any language like starting with A. Like starting with A. Any language you consider, for example, starting with A. Tell me, minimal DFA has how many states? For this language, minimal DFA has how many states? Minimal DFA has 3 states. Yes or no? If your alphabet is A, B, then remember for this language, minimal DFA has 3 states. But I can create DFA with 3 states, 4 states, 5 states, 6 states, 10,000 states, 1 billion states. I can do that. Do you agree with me? DFA with these many states are possible for this language. For this same language, these DFA are possible or not? Did you understand my point? If you consider this language, for this language, the minimal DFA has 3 states because minimal DFA is unique. Minimal DFA is unique. But remember that I can create DFA. DFA is not unique. DFA is not unique. I can create DFA with 3 states, 4 states, 5 states, 10,000 states. I can create DFA with 1 billion, 1 billion states. Yes or no? So now you tell me the answer for this question. For NFA with n states, you have NFA with n states, there exists equivalent DFA with more than 2 power n states. Yes, this statement is true. Yes or no? Agree? Because what you can do, from this NFA which has n states, notice what you can do. From this NFA, you can find minimal DFA. First, you can find minimal DFA. Okay, first you find minimal DFA. You already know that minimal DFA will have at most 2 power n states. Okay, now what you can do, in this minimal DFA, you can add unreachable states. Okay, you can add any number of unreachable states. You can add any number of unreachable states. Okay, then you will get DFA with any number of states. Yes or no? DFA with any number of states you can get. Is this point clear? Please tell me, did you understand? Very simple. This NFA you can convert into minimal DFA. The minimal DFA will have at most 2 power n states. Now you can add any number of unreachable state and you can get DFA with any number of states. Yes or no? Agree? So you can get DFA with more than 2 power n states. Yes, that is true. You can get it. Please tell me, did you understand? Let me know the answer for this question. For NFA with n states, there exists equivalent minimal DFA with more than 2 power n states. This statement is false. This statement is false because equivalent minimal DFA will have maximum 2 power n states. Okay, and this is unique also. So you cannot create more than one minimal DFA. The minimal DFA is unique and also it will have maximum 2 power n states. Now you tell me the answer for this UGC NET question. This UGC NET 2012 question. Let L be set of accepted, let L be set that is accepted by NFA. Okay, means there is a NFA. This NFA is accepting this language L, and the question is saying that number of states in this NFA that is Q. Okay, so remember there is a NFA for L. The question is saying that there is a NFA for the language L, and in this NFA there are these many states. Okay, these many states you have in the NFA. Now the question is asking the maximum number of states in equivalent FA that will accept L. Then tell me, in this question, is this question talking about minimal DFA? See, the maximum number of states in the equivalent minimal DFA. See, if the question is talking about minimal, then answer is very easy. If the question is asking you minimal, let's assume the question is asking you equivalent minimal DFA, then answer is very easy. The maximum number will be what? The maximum number will be option D. Yes or no? The maximum number will be option D. Agree? If the question is asking minimal, then answer will be option D. But you tell me, here the question is not asking minimal. Here the question is not asking minimal. Okay, see, the question is not asking minimal. Question is not asking minimal finite automata. Yes or no? It is not asking minimal finite automata, or I can say it is not asking minimal DFA. Then tell me, in this situation, can I say that maximum you will have 2 power Q state in the DFA? Tell me. Now you can see that you can have any number of states in the DFA. Yes or no? So in this question, because the question is saying that maximum how many states will be there in the equivalent DFA, that can be any number. Yes or no? That can be any number. There is no maximum for DFA. See, for DFA there is no maximum. There is no maxima exist. You can create DFA with 1 billion states. There is no maximum exist for DFA. For DFA. But remember, maximum exists for minimal DFA. Okay, see, maximum exists for minimal DFA. Exist for minimal DFA. Okay, and what is that? Maximum exists for minimal DFA, and what is that? That is a 2 power n. Okay, that is 2 power n. This is the maximum for minimal DFA. But maximum does not exist for DFA. You can create DFA with 100 state, okay, 1000 state, maybe 10,000 state. You can create DFA with 1 crore state. Yes or no? So remember, for this question, actually no option is correct. But you can understand what the question maker is thinking. See, the question maker is thinking that answer will be option D. Yes or no? In question maker's mind, the answer is option D. But the question maker is not creating a good question. See, this is a UGC NET question, so you don't have to worry about it. What is the reason? Because if you see all the GATE exam question, they are mentioning equivalent minimal DFA. Did you notice one thing? So far, we have done all the GATE exam question. In those questions, did you notice one thing? They are always asking you equivalent minimal DFA. Notice this GATE 1987 question. The minimal word is there. Okay. Notice this GATE 2001 question. The minimal word is there. Okay. Minimide. Yeah, you can see the minimal word is there. Yes or no? This is the minimide. Okay. Next, you see this GATE 2008 question. The minimal word is there. Okay. Is this clear? You can see this GATE 2018 question. Look at this GATE 2018 question. The minimal word is there. So this is what I am saying, that every GATE question is asking you number of states in the equivalent minimal DFA. But this UGC NET exam question is asking you number of states in the equivalent DFA. So that is the reason this question is poor. In this question, no option is correct, but the question maker will give you marks for option D. If you are attempting this UGC NET exam, the question maker will give you marks only for option D, remember, because the question maker has created a very poor question. It is a very poor question because it is not asking you number of states in the equivalent minimal DFA. The minimal word is very important. Okay, because DFA is not unique. You can create DFA with any number of states. You can create DFA with 10 crore, 10 billion number of states. You can do that. So there is no maximum upper bound for DFA. Okay. So I hope you understood everything. So far, whatever we have seen, did you understand? Please tell me. Tell me the answer for this question. For every NFA with n states, you have NFA with n states, there is equivalent DFA. There is equivalent DFA with exactly 2 power n states. This statement is true or false? For every NFA with n state, you have NFA with n state, there is equivalent DFA with exactly 2 power n states. This statement is true. Yes or no? This statement is true. Why this statement is true? Again, very simple. You have NFA with n states. Okay, you have NFA with n states. Now, what you can do from this NFA? What you can do? You can convert it into minimal DFA. Tell me how many states in the minimal DFA? The minimal DFA, how many states will be there? There will be 2 power, maximum 2 power n states. Now, what you can do? The question is asking equivalent DFA, not asking equivalent minimal DFA. Question is not asking you equivalent minimal DFA. Question is asking equivalent DFA. So what you can do here? You can add unreachable states, and you can get a DFA with exactly 2 power n states. See, you can add some unreachable states. You can add some unreachable states to make number of states exactly 2 power n. Can you do that? Can you add some unreachable states to make the number of states exactly 2 power n? Please tell me, can you do that? Let me know. See, you have NFA with n states. The minimal DFA will have at most 2 power n states. Now, if the minimal DFA has 2 power n states, then that is fine. Yes or no? If minimal DFA has 2 power n states, that is fine. Now, if minimal DFA does not have 2 power n states, then what you can do? You can add some unreachable states, and you can make a DFA, and we can make a DFA with exactly 2 power n states. We can make a DFA with exactly 2 power n states. Is this point clear? Please tell me, did you understand this? Let me know. Understood this? We can make a DFA with exactly 2 power n states. Any doubt here? See, a student is saying, sir, more than 2 power n also possible? Yeah, that is possible. But the question is asking what? That is possible, I agree. I am saying that, see, very simple. If you have NFA with, let's assume, 3 states. If you have NFA with 3 states, then what you can do? The minimal DFA, how many states will be there? Tell me, how many states will be there in the minimal DFA? In the minimal DFA, how many states will be there? Let's assume that there are 6 states. Okay, assume there are 5 states. See what I'm saying? I'm saying minimal DFA has NFA has 3 states. This given NFA, let's assume this has 3 states. Okay. Now assume that minimal DFA has 5 states. This I'm assuming that minimal DFA has 5 states. Now tell me, can you create a DFA with exactly 2 power n states? Now, can you create a DFA? Can you create a DFA with exactly 2 power n states? Yes, of course. What you need to do? You need to add 3 unreachable states. Yes or no? Add 3 unreachable states. What you will get? You will get equivalent DFA with 8 states. With exactly 8 states. Did you understand this? Let me know. So is this question clear to everyone? Please tell me. Understand this question. Read the question carefully. The question is saying you have NFA with n states. Then there exists equivalent DFA with exactly 2 power n states. This statement is true. Okay, because what you can do? You can create this type of DFA by adding unreachable states. You can add some unreachable states. You can add, and then you can create a DFA with exactly 2 power n states. For example, if you have NFA with 3 states, let's assume minimal DFA has 5 states. Let's assume, I'm assuming that minimal DFA has 5 states. Then what I will do? I will add 3 unreachable states and I will create a DFA with exactly 8 states. So this statement is true. Do you agree? Let me know. In the same question, if I ask you minimal, in the same question, if I ask you equivalent minimal DFA, in the same question, if I ask you equivalent minimal DFA with 2 power n states, now this statement will be false. Now this statement will be false. Okay, is this point clear? So I hope you understood the difference between this question and between this question. Here equivalent DFA with exactly 2 power n states, and here minimal DFA with 2 power n states. So I hope you understood. So remember, for this minimal, this statement will be false. Okay, but if the question is asking you any DFA, then this statement is actually true. Okay. Tell me the answer for this question. This is nearly 2016 question. The same question has come in the UGC NET exam. Tell me the answer. The question is saying, given two DFA M1, M2, they are equivalent if. When can I say that two DFA are equivalent? The same question here. Two finite automata are equivalent if. So this we already know that two machines are equivalent if they recognize the same language. Okay, in theory of computation subject, equivalence of automata, what that means? Two machines are equivalent if they recognize the same language. So for this question, answer will be two DFA are equivalent if they recognize same language. Yes or no? Their language is same. They accept the same language. So for this question, answer is option B. And for this question, two FA are equivalent. Two finite state machines are equivalent if they have same language, means they recognize the same set of tokens. So the answer will be option C. Actually, here remember, token means string. Token is same as string. Okay. So they recognize same set of strings. Okay. They recognize same set of strings. So for this question, answer will be option C. Tell me the answer for this question. This is nearly 2017 question. What is the relationship between DFA and NFA on the basis of computational power? Who is more powerful? Tell me. DFA, NFA, they are equally powerful. Yes or no? This we have already seen that. A language is recognized by DFA if and only if it is recognized by NFA. If a language is recognized by DFA, it is also recognized by NFA. If a language is accepted by NFA, then it is also accepted by DFA. This we already know. For every DFA, there is NFA. For every NFA, there is DFA, accepting the same language. So you can see that NFA, DFA, they have the same language recognition power. Okay, yes or no? DFA, NFA, they have the same power. So they recognize same set of languages. Any language that you can recognize using DFA, you can also recognize using NFA. Similarly, any language that you can recognize using NFA, you can also recognize using DFA. So they have the same computational power, or I can say they have the same language recognition power. Okay. So that's it. Thank you, everyone. Please tell me, did you understand everything in this lecture? In this session, everything did you understand? Let me know.